Good morning to Miss Irma. So we are from Group 4. Today we are going to presenting about analyzing honey extract using thin layer chromatography. So we have done the research about this topic in the Journal of Pharmaceutical and Pharmacology. So before I start, I'm going to introduce myself and my group members. Start with me. My name is Muhammad Fikri. My group members consist of Shazza Fatini, Siti Nurbaikis, Auni Nur Ain, Alia Dawiyah, and Pritiba. We had chose honey for the type of sample for this research. Okay, so honey has a natural sweetness carries for its unique flavor and also has potential health benefits. To gain the potential health benefits, we must extract the honey by using thin layer chromatography method, which is an analytical technique used to separate and identify the components of complex mixtures. In the context of honey extraction, thin-layer chromatography plays a crucial role in identifying and quantifying various compounds present in honey, such as sugar, organic acid, phenolic compounds, and other bioactive substances. By using thin-layer chromatography, by using this method, scientists and researchers can gain insight into the composition and quality of different types of honey, as well as detect any potential adulteration and contamination. Okay, so the use of thin layer chromatography in honey analysis involves the application of a small sample of the honey extract into a thin layer of adsorbent material such as silica gel or alumina on a glass or plastic plate. So that's all from me.
A very good morning to Miss Irma and my fellow friends. I am Pritibha Subramanian. I am excited to share the insights from the journal that we studied, which is a comparative studies of antibacterial and antioxidant activities of wild honey, which is sunflower and eucalyptus, and commercial honey. First of all, I would like to talk about the sample sources of the honey. Let's start with the sample that they analyzed in the journal. The study focused on various types of honey, specifically two local honey, wild honeys, which is eucalyptus and sunflower, and a commercial honey known as Kurshi honey gold. For the collection and sources locations, these honeys were located and collected from the different localities in Azad, Jammu and Kashmir, Pakistan. Sunflower and eucalyptus honey were sourced from Kail in the Neelam Valley and Lipa in the Jhelum Valley of the Muzaffarabad. For the sample preparation, moving on the preparation of the samples that they did in the study, we ensure they ensure the meticulous prepared by the collecting honey directly from the combs. To maintain the purity, they remove unnecessary materials such as sticks, dead bees, wax, and comb particles by straining through the cheesecloth. In this slide, I will talk about, first of all, I would like to talk about the concentration level that they analyzed, and they prepared different concentration of honey samples. These included 5%, 15%, 20%, and 50% achieved through the serial dilution of original 100% honey with double distilled water. For the storage, they preserve the integrity of their prepared concentration. They store them at controlled temperature of 4 degrees Celsius, providing a stable environment for the further process. For the analysis method, they delve into the methods that employed for their analysis. They use two key approaches to assess the properties of these honeys: antibacterial activity and antioxidant potential. When we look into the antibacterial activity, for antibacterial activity they utilize well diffusion and minimum the inhibitory concentration assays. This method allow us to evaluate the effectiveness of the honey against the range of bacterial strains. Moving forward, the antioxidant potential, shifting their focus to antioxidant potential, they employed the ABTS assay, which is 2 aziboys and 3 ethylene zoline and 6 sulfonic acid. This assay helped to gauge of the ability of the honey's scavenge of. Lastly, for this slide, chemical screening, which is thin layer chromatography, to understand the bioreactive constitutions of the honey, they turn the thin layer chromatography using chloroform extracts that they identify the presence of the alkaloids, polyphenols, flavonoids, and steroids. For the statistical analysis, their data analysis was robust, employing two-way ANOVA to ensure the statistical significance. They set the threshold at p minimum by 0.05 to determine the validity of their findings. In conclusion of my presentation slide, the study encompasses the collection and preparation and analysis of various honey samples through the meticulous process and advanced analytical methods. They aim to evaluate the antibacterial and antioxidant activities while identifying key bioactive constituents. So to wrap up my part, our their findings suggest that honey could serve as cost-effective source of the bioreactive compounds with the potential to combat bacterial infections. The superior inhibition of bacterial pathogens, even compared to the common antibiotics, positions honey as promising as the antimicrobial agent. So only that from me. Thank you.
I'll be presenting about the TLC parameters. In this study, aluminum TLC plate silica gel coated with fluorescent indicator F254 were chosen, and we also chose the size of 15 centimeters length and 20 centimeter width for these applications. So we chose silica gel because it's a common stationary phase due to its polarity and versatility in separating a wide range of compounds. And for our solver system, for the mobile phase, we have chloroform and methanol, ethyl acetate and acetic acid, N-hexane and ethyl acetate, and N-hexane and acetone. And for our stationary phase is the silica gel. For the application of samples, we use spotting, and it should be carefully performed using a capillary tube or micropipette. So this ensures precision in spotting and helps in obtaining clear and distinct spots. For a timber, so we should choose a suitable size for the plates with a tightly fitting lid and with a flat bottom or twin trough is usually used. And then it should be closed chamber environment because it would maintain the consistent condition. And for our visualization methods, we use a UV light and staining with anisaldehyde. So UV lights allow the detection of compounds that absorb UV radiation while staining enhance the visibility of spots. And for the RF value, the calculation of RF value for each separated spot is essential for quantifying the relative migration of compound and also provide a measure for comparing results between different experiments. And the wavelengths that we chose is 254 nanometers and 336 nanometers wavelengths during the UV visualization. Thank you.
So next, I'm Alia Daria Azman. My metric number F1024 will present the next slide. By interpret the data using TLC instrument for food analysis, which is honey. So by using different screening system, we are used to get better resolution of components. So basically the curd extract of honey and impressive diversity of the chemical constituent can be seen. So they were observed under short and light wavelength. So prominent color bands of different crude extract were observed by staining with anisaldehyde and also observed under UV. So there are four graphs of three different spots. So I will take part of solvent system 1 and solvent system 2. So for solvent system 1, using chloroform and methanol, there are three replicates. Also, the result revealed that methanolic solvent is much better for separation of components than less polar or non-polar system. So the result for chloroform methanol solvent system, as or we call as a mobile fail for TLC, had reasonable similarity with some earlier reports, stating that non-polar compound like hydrocarbons, fatty acid, and wax present in neutral product and could be extracted. So I will extract the data of TLC. So from the graph for solvent system 1 using chloroform methanol, for spot 1, commercial honey showed a higher irritation factor compared to others by 0.8 centimeter. So the spot 2, commercial honey also showed the highest value for retention factor compared to others honey, but lower than in spot 1. So spot 3 show only two spot commercial, which is commercial honey and eucalyptus honey. So the higher in spot 3, the commercial honey, while sunflower honey no spot been seen. So which means it's more polar and low soluble. So we'll continue with the next slide, which is a solvent system 2. The solvent system 2 use ethyl acetate and acetic acid. These are two organic solvent can dissolve some compound in honey. So as spot 1 has a higher retention factor for commercial honey, which means it reacts more strongly with ethyl acetate, acetic acid with RR value almost to 1.0 cm. So the commercial honey compound in spot 1 may have higher or more non-polar compound that can react with solvent system compared to other honey. The result also same goes with the spot 2. It react more strongly than eucalyptus honey and sunflower honey. So S3 has a lower retention factor compared to S1 and S2, which means it reacts less strongly, but only eucalyptus honey show with the spot. So this difference in polarity can cause the compound in sunflower honey interact differently with stationary phase. So from overall show that sunflower honey has more and higher affinity towards stationary phase because of the lowest retention factor in centimeter from the graph. So by comparing between two graphs, the highest value of retention factor for identify of various compound goes to commercial high.
My name is Siti Nubaikis binti Mustafid. My matric number 23DBK21F1039. Today, I want to present interactive data of the essay method, which is graph 3. The CH is highest retention factor between EH and CH during S1. CH is slightly higher than EH. It is commonly used to solve a system to extract non-polar compound from natural production. Is the efficiency of extracting lymphocyte compounds such as fat, oil, and contain antioxidation is more suitable to exotic info lipophobic antibiotic compounds that are solvent in non-polar solvent. Efficiency of exotic lymphocyte antioxidation such as current and as certain phenolic compound. Our fourth graph, which is the hexane and ethyl acetate, which is 9.5 Nisba 0.5. In the graph, the S1, CH are no data recorded, and the EH are slightly lower than the peak of S1, which is CH. S2, CH is no data recorded. CH is higher than EH and SH, but the EH is between 8. The data solvent between SF4, hexane, and ETOC is non-polar to the modality polar solvent system. It is biofixed solvent system that combine the non-polar nature of an hexane with the modality polarity of ethyl acid. It is often used to extract the bond range of compound, including the both non-polar and modality polar constituent.
So by the color of honey that been extract, use chloroform. It will show pink to yellow pen when stained with anisaldehyde or sulfuric acid. When the solvent touch the chloroform extract of tree honey, this study can know what compound that be spot and indicate by doing research. So the spot show this specific spot indicate the presence of phenol in the extract. So the spot shows seen the phenol compound in the honey extract. So the purple color spot on staining will indicate the presence of hydroquinone and other hydroxyl phenyl propane derivatives. So the purple color shows the hydroquinone and hydroxyl phenylpropane derivative. This compound contribute to the antioxidant properties and potential health benefit associated. So next, they are found a brownish color that indicate the presence of terpenes. So terpenes known for their aromatic qualities and can have potential health benefits too. So pink to brown and yellow color under the UV light indicates the presence of alkalides.
Uses evidence that show this technique is the best method available for the analysis. Chloroform extract from tree honeys show pink to yellow bands when stained with anisaldehyde or sulfuric acid. Purple spot on staining with the same reagent in this study indicated the presence of hydroquinone and other hydroxyphenylpropanoidif derivative, which is brown color indicating the presence of terpenes, and pink to brown and yellow color. And then results have a reasonable similarity with some earlier reports stating that non-polar compounds such as hydrocarbons, fatty acid, and wax found in natural products can be extracted with a chloroform or methanol solvent when system. From the journal, the methanol solvent system is better for component separation than component less polar or non-polar system. However, ethanol water or acetone water were better solvent compared to ethanol or acetone for the separation of various components. And then from the journals that prove the honey components can be successfully separated using the thin layer chromatography method. So these are references that use to study about the journals. So that's all from our presentation group. Thank you.